Hi folks, it's Miss Fairman. I am here to talk you through the notes for Part C, Chapter 5, Part C, or Part 2 of our exponential functions. Hopefully this video won't take too long. Obviously I'm not there today. Your job is to watch this video and work through the examples with me, and then you will complete the practice that is included on separate paper. So complete the practice on separate paper, and then you will submit it to your substitute, and they will give it to me, and I will check it out. And then we will review everything together next week. So just to repeat, we'll work through this together. We'll work through this video together. And then when you get to this part, you will do these problems on separate paper, and then you will turn them in. Everybody should have their own copy. Everybody should have work showing, and you can work together, but make sure that you have your own copy. And I should note, this should be done without a calculator, sort of. That'll make more sense in a minute. All right, anywho, let's go back to the beginning and let's start. So we're going to talk about solving exponential equations today. And just as an example or a definition, an exponential equation is an equation in which the unknown occurs as part of the index or the exponent. So that means that we are looking at things like 2 to the x power equals 5. So we're looking for the number that when we raise 2 to that power, we get 5. Or something like 3 times 4 to the x equals 18. So notice that the exponent, the variable, the thing that we're going to be solving for, is part of the exponent. So in the past, you've probably solved some of these before, and you might have used logs to solve them. To begin with, we're going to do that eventually, but to begin with, we are going to use the idea that we can equate the exponents or the indices, so we can set them equal to each other and solve, and then we can use our graphing calculators actually to check our answers. Okay, so what that means is if we're going to equate the exponents, we need to get our equation down to a stage where we have a base with an exponent equal to the same base with a different exponent. And if I have that, if I have a to the x equals a to the k, then we can conclude that x must equal k. So as long as we have the bases the same and only a base to the exponent equals only a base to the exponent, then we can just take the top part of the equation or the exponents and set those equal to each other. All right. So if you can change the equation so that you have the same single base on each side, then you can equate your exponents to solve. So let's look at some examples. In this first example, we have 2 to the x equals 16. So we have 2 to the x, that's our base with our exponent, but 16 is not in base 2. So we need to rewrite 16 as 2 to a power of something. In this case, 2 to the 4th power is 16. Now that we have the same bases, we can equate our exponents. We can write our little 3 dots, which means therefore x equals 4. And that problem's done. It's solved. If we look at example B, same situation. We have 3 with a more interesting exponent, x plus 2. And then we have 1 over 27. So first thing we can think about is we want this to be 1 over, and I want a base 3. 3 cubed is 27. And then I want to bring it up to the numerator, so this would be 3 to the negative 3. So I write the right-hand side of my equation as 3 to the negative 3. Now that the bases are the same, we can equate our exponents. So therefore, x plus 2 equals negative 3. We can subtract 2 from both sides, and we get x equals 5. Great. let's look at our next equation. So here in these next two examples, we don't have bases that match each other, so we're going to have to change both sides of the equation. Think of a number that I could write as an exponent that relates 4 and 8. Hopefully you came up with 2. So on the right-hand side, we could write 2 to the 2x, because this is 2 squared to the x power. And on the right-hand side, we can write 2 cubed. Therefore, we can equate our exponents, and we get 2x equals 3. Divide by 2 on both sides, and we get x equals 3 halves. That would be our solution. For part B, we need to rewrite 9 as a base 3. So this is 3 squared, but there is already an exponent there of x minus 2. So that squared, that 2 is going to be distributed through all of those parts. On the right-hand side, we would have 3 to the negative 1. So now we have the same bases, so we can equate our exponents. Therefore, 2 times x minus 2 equals negative 1, or 2x minus 4 equals negative 1. And now we can just solve this equation for x. So add 4 to both sides, and we get 3. Divide by 2 again, and we get 3 halves again. That's just a coincidence. All right, let's keep going. So these were just basic equations. Say, for example, I have an equation that has 3 parts to it. What I want you to do is I want you to think about this being in quadratic form, where we have a coefficient of a times something squared plus the coefficient of b times that same thing plus c equals 0. So in this particular problem, if we rewrote it so that it is in quadratic form, we would have 1, that's our coefficient, and then our thing that's being squared is 2 to the x squared. Then we have plus another coefficient of 1, and our thing is 2 to the x. And then we have minus 20 equals 0. So this is in quadratic form. And if I have a quadratic, what methods do I use to solve quadratics? Well, I can factor, I can quadratic formula, I could complete the square, etc., etc. In this case, we want to check to see if we can factor first. So we are looking for factors of 20 that would combine to give us 1. So in this case, and a positive 1 at that. So in this case, factors of 20 that would combine, negative 20 that would give us 1 are 5 and negative 4. So we know that we're going to end up with 2 parentheses where we're going to have a positive 5 on one side and a negative 4 on the other side. And this thing, this 2 to the x, that is like what we would normally put in as our variable. All right, so once we've factored it, what do you do once it's solved, or sorry, what do you do to solve once you have it factored? Well, you use your zero product property. So I'm going to say 2 to the x minus 5 is going to equal 0, or 2 to the x minus 4 is equal 0. So let's start here on the right. 2 to the x, add 4 to both sides. 2 to the x, rewrite 4 as base 2, so 2 squared. Therefore, we can equate our exponents and we get x equals 2. On the left-hand version, we have 2 to the x and we can move the 5 over. Oops, sorry, that was a plus. And so when we move it over, it is a negative 5. Well, think about this, pause here. Is there an exponent? First of all, there's no way to write negative 5 as base 2. Second of all, there's no exponent that would give us a negative value. So even if this 5 weren't 5, even if it weren't a negative 5. If it was a negative 2, it doesn't matter because there's no exponent of x that would make this value negative. Remember that negative exponents just make fractions. They don't make negative values. So here, there is no solution. A solution on this side does not exist. So that means we just have the one value there. All right, so those are our examples, but let's see, what if we had something that we couldn't write in the form of equating the exponents? So let's go back to our first page and get our calculators out. On this first on this first problem, we couldn't check it by actually using a graph. And we can go to our calculator, we can type in y1 and make that 2 to the x. And then we can type in y2 and make that 16 from our original problem. And what we will find is we'll have a graph that does something like this. That's the 2 to the x part. And then the y equals 16 is going to be just a horizontal line. So this is our y equals 16. This is our y equals 2 to the x. We can then use our calculator in order to find that intersecting value. So as long as you can see the place where the intersection occurs on your screen, you can find the intersection. So in this case, we're probably going to have to change our window. So you can hit window, and I would make my y max like 20 or something like that. That will change my screen so that it makes it easier to see. And then I can use the steps second, calc, intersect, and I can work through those parts. Okay? Let me take you to my calculator and we can go through these as an example. So just give it a second. The calculator is slow to open. Okay, so here we are with my calculator screen. I'm going to go to y equals. Let me clear everything that's there. And we are going to type in, what did I say? 2 to the x. Oops. To caret x. And then we're going to type in 16. And then I'm going to hit graph. So there's my curve. And notice that the horizontal line to the 16 isn't showing. That's because it's not on the screen. So I can go to window. And I can change my y max to make it bigger. So I'm going to change it to 20. I guess. Hold on. I'm going to change it to 20. Go ahead and hit enter. And then I can go back to my graph, so I can hit graph again. There we go. All right, now I have the intersecting spot, so I can hit second, trace, and I can choose 5 for intersect. I need to put my cursor sort of close, so I'm using the right button to move my cursor close to the intersection. I hit enter. For the second curve, I hit enter. I guess I hit enter. And then I can see that my intersection is 4 and 16. So the answer that we got was x equals 4, which is the answer that the graph showed us. So for any of these graphs, you can actually use that calculator step in order to, any of these problems, you can use that calculator step to test them and see if you got them right. All right, now is a good time to pause the video or stop the video, share your answers with your friends, ask any questions, and then go ahead and get started on these separate problems. Remember, you're going to submit them, and I'm going to count them. I think I said 6 points in the gradebook. Thanks so much.